Hi, welcome back to another video. So today we're going to be talking about inverse and direct proportions, conclusion calculations, and lastly we're also going to be talking about percentage calculations. So let's get right into it. You have two types of relations, you have or proportions. So you have a direct and you have a inverse relation. What's the difference? A direct relation means you increase one value, the other one is also going to be increased. Okay, this is a very short topic, so it's not much to talk about. It's basically all just applications of these two ideas. So if you're going to pay attention at any point in the video, do it now. Direct relations basically mean you increase one quantity, the other one is also going to be increased. Inverse relationships mean you increase one quantity, the other one is going to be decreased. So you have two arrows up, or you have one up, one down. That's basically the only option you have. The only two options you have. So a direct relation, what does it mean? Well, you say you have 100 workers and how much you need to pay them. And say you have 1,000 workers and how much you need to pay them. Well, since you have 10 times more workers, you need to pay 10 times the amount of money. That's basically an example of a direct relation or proportion. While an inverse proportion would be, say that you have one worker, how much time does he need to do a project versus if you have 100 people doing the same project. Well, if you have 100 more people, it's gonna take 100 times less time. So you increase this one by 100, you're gonna decrease this one by 100. You increase this one by 100, you're also gonna increase this one by 100. If you buy 100 times more teddy bears, you're gonna have to pay 100 times more the price. So those are the two ideas. Now, how do you apply them? Well, that's what we're gonna call a conclusion calculation. So what you do is you write the same variables in basically the same column. So let's say you have a direct relation, so you have the amount of things you buy, or let's say items for short. So you have items here, and then price on the other side. So you say, okay, so if I buy 10 teddy bears, so that's 10 items, then I have to pay 20 euros, okay? What if I buy 100 teddy bears? Well, how much do I need to pay then? Well, since you buy 10 times more, you're gonna have to increase this one by 10 times as well. So that's gonna be 200 euros. Okay? Or what you can do is you can say, okay, so I don't know one of these quantities. In our example, we didn't know this one. So what we could have done as well is you say 10, 20 euros, 100, and X. And what do you do now? Well, you just cross multiply. 10 times X is going to be the same as 100 times 20 euros. So 10X is 100 times 20 euros. And then you divide by 10, so you only get X. So it's going to be 2. And X is going to be equal to 200 euros. And that's the same thing. So you have the two options. And for this is for a direct proportion. So a direct proportion, you're gonna cross multiply them like this. In an inverse proportion, you would horizontally multiply them. So like this. Now let's do the example for the horizontal one. Say you have 10 workers doing a job, and 10 workers need 10 hours. Okay, so workers time. 10 workers need 10 hours. We're just gonna write H here. So 10 workers, 10 hours. How much workers do you need if you want it to only take 2 hours? Okay? Well, here, the principle is that if you increase one, then the other one is going to be decreased. So if we decrease this one by 8, or we have to actually use division and multiplication only here. So to get from 10 to 2, what do? Well, you can only use multiplication, or you can use division. In this case, we're going to be using division. So 10 divided by what gives us 2? Well, 5. And if we divided this side by 5, we have to multiply the other side by 5. So you need 50 workers to get the time down to 2 hours only. Now, what if we wanted to use the cross multiplication again? Well, you wouldn't cross multiply. Again, you would write it like 10, 10, x, because this is the unknown quantity, and 2. Then you would just multiply them like this. So 10 times 10 is going to be x times 2. So it's going to be 100 is going to be equal to 2x. And x is going to be equal to 100 divided by 2, which is going to be 50. So again, we did the same principle. If you have a lot of values, what you can do is you can just write them in a table. So the exercise might say you have 3 workers and they need 20 hours. Okay? So workers, hours. Okay? 3 workers need 20 hours. How many workers do you need to get down to 5 hours? And how many hours do 20 workers need? And let's also say, what if you only have 7 workers? So what do? Well, you can just see which row has both values. In our case, this is the only row that has both values. Great, what can we do about that? Well, we're trying to get one of them down to 1. So in our case, let's say we try to get this one down to 1. Or if you can see a quicker path, you can also take it. So you imagine math being like a winding path. You have this as the slowest solution, okay? But along the ways, you might find shortcuts. And if you do find a shortcut, by all means, take the shortcut. Because what we could do is we can, say we can divide this by 3. And then we can multiply this by 3. So we have that one worker needs 60 hours. And then it's a bit easier to get into 7, for example, or into 20 than from 3, because 3 can't easily be multiplied into 20, okay? But what we also see is that it's quite easy to go from 20 into 5. So if you want to go from 20 hours to 5 hours, you divide by 4. So this one is going to be multiplied by 4 then, and it's going to be equal to 12. So 12 workers are going to need 5 hours. Okay, what about 20 workers? Well, again, we said that it's kind of hard to multiply 3 into 20 or 12 into 20. So we first multiply it into 1, and then we're going to multiply it into 20. Okay, so now we're going to go from here to here. So we're going to multiply this one by 12, and we're going to divide this one by 12. Okay, so as you can see, the concept is always the same. You multiply one and you divide the other. So if we multiply 1 by 12 and we divide 60 by 12, we're going to get 5 here. Okay. Oh, my bad. We wanted to go into 20, right? Yeah. Okay, so this one. You go times 20, and this one you go divided by 20. So what's 60 divided by 20? Well, it's going to be 3. Now, what about 7? Well, you multiply this one by 7, and you divide this one by 7. 60 divided by 7, and that doesn't really exist. It's like 56, which is going to be 8 and a bit more, okay? So it's going to be 8 and a bit more than half, okay? 8.6 or something like that. So that's basically how inverse proportions work. Now let's take the last example here for inverse proportions and converse proportions or direct proportions. Say that you have a musician playing a song, and one musician needs 2 hours to play a song. Okay? How much time would 5 musicians need? Okay, so X. Well, I'll give you like a few more seconds to think about it. So 1, 2, 3, 4, 5. Okay, I hope you basically had enough time. And if you try to do this or this, you're mistaken. Because are the values even proportional? Are musicians proportional to the amount of time a song lasts, okay? Are they related? They are not related, okay? So these values are not related. So if we change this value, this one is going to remain the same, okay? So this one is what we call invariable, okay? So since we changed this one, and there's no connection between them, it doesn't exist, this one is just gonna remain the same. So it's gonna be 2 hours. So make sure that the values you're manipulating are actually related, and make sure you know how they are related. Okay? We're gonna talk a bit more about this in the topic of linear functions, because what you're gonna see is that this is just a linear function. So you're gonna see that these two values are related by times 2, okay? As you can see, whichever row you look at, to get from one row to the other, you just multiply by 2 or divide by 2. Doesn't really matter. And for this one, they're related that the product is the same. So 50 times 2 is the same as 10 times 10. See? So in this case, we would write x times y is a constant, because no matter what these two values are, x and y, their product is always going to be the same, while these two values, y is always going to be something times x, and this is a linear function. But that's going to be for another topic. Now, let's go to percentage calculations. So what would a classic example be? Say you have a piece of clothing that costs $20 at 100% price. So 100% is $20, euros, whatever. How much is it gonna cost if you have a 20% discount? Now this is the slow way to do it. You first calculate the discount, you get the discount, how much the discount is in euros, and then you subtract that from the original price. Okay? So percentages are always just direct proportions, okay? So you have x times 100% is gonna be 20 euros times 20%. So x is gonna be 20 euros times 20% divided by 100%. Percentages are reduced, and then we can also cross these zeros, okay? So you get that it's gonna be 4, okay? So 20% of 20 euros is gonna be 4 euros, okay? And then they say, okay, so it's a 4 euro discount, so the discounted price is gonna be 16 euros, because that's gonna be 20 minus 4. And they'd be correct, but they would also be very slow. What's the faster way to do it? Well, you know that if something is basically 20% off, it's at 80% of the original price. So you just multiply the original price by 80% and you get your result. 20 euros times 80%, and the sign for percentages is basically just 1 divided by 100. It's the same thing. It's gonna be equal to 20 euros times 80 divided by 100, or rather 0.8. Okay, so 20 times 0.8. So you have 2 times 16, which is 2 times 8, which is 16 euros. Okay, so as you see, you can just multiply by the final result. And that's a much quicker way and also much more efficient, because it basically implies the whole thing. Okay, what we do here is we get, okay, so we have 100% times x minus 20% times x, and then we factor out x, and then we get 100% minus 20%. Okay, And this is just basically 1, so we get x minus 20% of x. So as you can see, this is what we did here. 20, which was x times 100%, minus 4, which was x times 20%. And this whole part, we basically just got from this. Okay? All of this is just basically to say x times 20%. It's really, really not a big deal. Okay? So that's how the long version would be. See, you get x is gonna be 80% here. Okay? So, and you can remove the parentheses then. X times 80%. Okay? Now, let's see how you can apply this idea. So, say that you see that something is on a 17% discount. Well, 17% off means that it's gonna be at 100 minus 17% of the original price. Well, what's that? That's 83%. So, if it was originally, let's say, 100 euros, then it's gonna be 100 times 83%, or 100 times 0.83. And what's that gonna be? Well, that's gonna be 83. And you get your result. It also works much better when you try to calculate some other things. So, for example, let's say you have a company, and let's say that you don't have to pay taxes if you buy something related to your company. So, if you have a tech company and you buy a computer that you review, you don't actually need to pay taxes on it. So, the computer might cost $1,000 or euros, but that is including tax. So, with tax. And you want to say, okay, so how much do I actually have to pay if I don't have to pay tax? Well, I don't know in other countries, but in my country the tax is 22% extra, okay? So we know that I had some price. The price I also actually have to pay, but we also added 22% as tax, okay? And then we got 1,000 euros. So basically what happened here? We had a price, x, then we added 22% of x times x, and we got 1,000 euros, okay? So if we factor out x, we get 1 plus 22% is gonna be 1,000 euros. And 1 plus 22% is just gonna be 1.22 times x is 1,000 euros. So now you just divide by 1.22. Okay? And you get how much it is without tax. Now, if we use a calculator, the amount is gonna be 100 divided by 1.22. It's gonna be approximately 819.67 euros. Okay, so instead of paying 1,000, you actually only have to pay 820 euros, which is like 180 euros cheaper. Now, how the other person might have gone and calculated it is just way too long. So please use this method. It also works much better if you have a chain of discounts. So let's say a product was at first, let's say it was 40 euros, okay? Then it went 15% off, okay? Because it was a sale. And then they realized they couldn't sell it, so they added another 20% off. And they say, what's the price after both of the discounts? Well, what is the important information here? First, it was 40 euros. Then it went 15% off. Okay, so to x, and then it went an additional 22% off, or what did you say, 20% off. Okay, so why? Here, we want to know why, the letter, not the question. And what does this mean? Well, this is 20% of this price. If it said it went off by an additional 20% of the original price, that would have been a whole different thing, and we might have been even able to sum these together and then apply a discount. But it doesn't say that. It says that they first reduced it by 15%, then by an additional 20%. So, what is this? This is basically 85% of the original price. Okay, so 0.85. And this is going to be 80% of the original price. So, 40 times 0.85 times 0.8 is the answer we're looking for. Okay? So 40 times 0.8 times 0.85 is going to be 27.2. Okay? So that's the final result. Now, let's say you have to reverse some percentages. You can also do that much easierly than you could using the conclusion calculation formula. So you can say that a clothing, after being discounted by 17%, so 17% discount, now only costs 100 euros. How much was it before? Well, so X times 0.83, these two numbers together should add up to 100, is gonna be 100. So X is gonna be 100 divided by 0.83, which is gonna be 120. Okay? And 0.5 approximately, but it doesn't really matter. So you can see it's much easier to flip them around. And what about if they ask for discounts? Well, that's also much easier to calculate this way. So let's say that an original piece of clothing is going to be 100, and then the new price is going to be 67. Okay? They want to ask you, they want to know how much percent off did they give. For this example, you should probably able to actually quite see it, that this is 33% off. And because you see these two numbers, 100% of 100 is 100. So 1% of 100 is 1. Okay? But basically what you can do is see what they want to know. Do they want to know the increase or the decrease? So the discount or the increase in price? 100 and then 67. If they want to know by how much they increase the price, you place it next to the lower number. So you see the increase. If you want to know how much it was decreased or discounted, you place it next to the higher number. Why does it work? Well, a discount is always going to be less than 100. So you're going to multiply by 80% or by 90%. They're not going to say, oh, we gave you a discount, so you have to pay 20% more. No, they're going to say, we gave you a discount, so you pay 20% less. So it's always going to be next to the higher number. And next to the lower number, if they increase the price, they're not going to say, yeah, we increased the price, you only have to pay 70% now. That doesn't make sense either. So you see if they want the discount, you place it next to the bigger number, and if they want a increase, you place it next to the lower number. And then you just solve for x. So x is going to be 67 divided by 100. Okay? And what's that going to be? Well, this is going to be 67 divided by 100, 0.67. I don't know why I had to use a calculator for that one. Now, this one is quite simple, but let's say that the original price was 67. Let's say you were playing a card game and you get a really rare card, and now suddenly they also make it a limited edition. So its price went from 67 euros to 100 euros. And they want to say, how much did the price increase? Well, 167. Since we're looking at the increase, x is going to be next to the lower number. So x is going to be 100 divided by 67. And that's going to be equal to 1.49. So it was a 49% increase, okay, in price. And this was a 67% sale, so it was only a 67% of the original price, so it was a 33% sale, okay? Because this is the number that you multiply, this is the final result, but when they ask you for the discount or the increase, they only look at the difference, okay? How much away from 1 is it? So this is 0.33 away from 1, okay? This is basically 100% minus sale percent, okay? So you get that 67% is gonna be 100% minus sale. So that's gonna be, if we turn it around, sale is 100% minus 67%, which is gonna be equal to 0.33 or 33%. Okay, and that's basically percentage calculation. So if you want a certain number, you just multiply it by the final percentage, okay? If you want to see, for example, so you have a 20% discount, so you multiply it by 80%, because that's 20% off, okay? If you want to see the increase, well, you would multiply it by 144% if it's a 44% increase. It's quite a simple concept, and I found that once teaching my students this, they had a much better experience with percentages. They also got less confused and they solved them faster. So that's it. That's all I wanted to talk about. I'll see you later. Bye.